All right, so I want to finish teaching intermediate measurements, and I want to talk about, we already talked about switching gears so that we're not doing larger to smaller, multiply and so forth with our 7th graders or even with our 6th graders. We want to start teaching them the cancellation of units technique and prepare them for high school so that they can do the problems in physics and so forth. For example, they will frequently have to change miles per hour into feet per second. They may have to do some frequency problems and things like that in physical science, and so they need to be able to convert units. The next thing I want to talk about is teaching techniques for the metric system. 5th grade, 6th grade, 7th grade. We talked about the metric system. The last time we talked about it, we were primarily dealing with your knowledge and understanding of it. So let's talk about teaching the metric system to 5th graders, 6th graders, 7th graders, primarily kind of making a transition there. With the decimal system, by the time they're in 7th and 8th grade, they should be very familiar with decimals and decimal place value. And so by 7th and 8th grade, we want to get rid of the idea of multiplying and dividing by powers of 10. We want to work totally off of place value. And yes, we are multiplying by powers of 10, but all we're doing is changing places. All we're doing is moving the decimal point. And by the end of 8th grade, they need to be able to work in the metric system and so forth, and be able to do metric to U.S. customary conversions, and they need to be able to do those main 4 that we've talked about. Inches to centimeters, and then they need to be able to do liters to quarts. They need to be able to do pounds to kilograms and miles to kilometers. If they know those 4 conversion facts, and you need to know those 4 conversion facts for the measurement test, they will be able to manipulate just about any conversion that they need to by doing a double conversion or so forth. We don't need to learn gallons to liters because we can always go gallons to quarts to liters. We don't need to learn feet to meters. We can go inches to feet, or rather feet to inches to centimeters and vice versa. So what I want to talk about today is teaching the metric system to 5th and 6th grade, and then to 7th and 8th grade. First thing, let's start with 5th and 6th. Keep in mind 5th and 6th are a little weak on their decimal math, especially the 5th grade. So what we want to do, first of all, is we want to separate the U.S. customary system away from the metric system. Do not teach them at the same time. We want to, I'm going to use the word divorce. We're going to divorce the U.S. customary system from the metric system, and we're going to teach the metric system alone. We're going to teach it as it stands alone. We're going to teach it as decimal place value, which is what it is. So we're going to throw away the flashcard that says 1 kilometer equals 1,000 meters. And we're not going to chant it with our English or U.S. customary system, are we? So we want to teach it as place value, and we want to get them to know the order of the system, and then we will start relating it later to the U.S. customary, just so that we can do U.S. customary conversions back and forth to metric and so forth. But when we are starting the metric system, we want to keep it separate from the U.S. customary system. It is entirely different. We are not going to memorize conversion facts. We are not going to multiply and divide by different numbers. We're going to concentrate on learning the order of the metric system, learning which place it goes with, and concentrate on moving the decimal. When we change places, we're changing places, we're changing units. It's the same as changing places. We're going to move the decimal 1 place per unit. And we are going to move it to the right to get our number larger when we are moving down the metric system, and we are going to move it to the left as we're getting smaller going up the metric system. But we don't want to teach it as multiplying by 1,000 to convert to kilo, because that only works for kilo to meter or liter or gram. We want to teach it as places and changing places and moving the decimal one place per change. You can do this. By simply memorizing the order of the metric system, not the meaning of the metric system. So that's what I mean by, in one sense, by divorcing the two, teaching them alone, teaching it as its own entity. They need to learn the order, not the prefix meanings as much. Well, yes, we need to know the prefix meaning because it coincides to the place value. But what I mean is we don't drill the measurement facts of the metric system because they are unnecessary. It's place value. We should be drilling the setup: kilo, hecto, deca, base unit, then deci, centa, milla, drilling the order, not the individual meanings. All right, and eventually, we are going to kind of delete a few of these guys in particular because they are placeholders, but we still need to memorize where they are. I've seen the stair step in the Bob Jones books and other places. You've probably seen it on the internet. We'll do meter, liter, gram. And then below the decimal, we have, behind the decimal, we have deca, centa, and milla. This works well too, but we still have to know the order: kilo, hecto, deca, meter, liter, gram, then deca, centa, milla. All right, and what happens as we go down, we're going to move it one step at a time, one place at a time, or we can do it vertically. All right. But what we don't want to do is do larger to smaller, multiply by 1,000, multiply by 100. We want to teach it as place value. And so when you are teaching it, first of all, teach it as it stands alone, divorce it from the U.S. customary system. Secondly, teach the order of the system, not the individual numbers. Not kilo 1,000. If we're going to do that, we have to say thousands place. And the base unit then is the ones place, the tens place, the hecto. But what we want to do is get the system as a whole down and just learn to move the decimal as we change, one place or one step at a time. All right? Because this is an entirely different setup than the U.S. customary system. Okay? There's no computation, there's consistency between the two, and so forth. It is a much superior system, so we want to, as we mentioned on Friday, we're going to constantly be giving them a pep talk, right? On how easy the metric system is. And so as you are teaching it, teach the order. Okay? And so then when they have to do a conversion, you can even make them write the order, kilo, or you can have them, let's say we're converting 3 kilometers equals how many decameters? They can write km, hm, dam. And if we have 3, we are going to get one place as we go across. So this is 2 units down, I move the decimal 2 places to the right. 1 place per step. And actually then too, it becomes easier if I have numbers, or more obvious, if I have numbers instead of zeros. Okay, so then I'm going to be moving it from one place at a time. So I have kilometer, 3.451 equals how many decameters. So all I need to know is the order, and then all I'm doing is moving the decimal point. Okay, do 5th graders, 6th graders, 7th graders have trouble with the metric system? Quite a bit. They're moving the decimal. Sometimes it's even difficult to figure out what they were thinking. It's like they, randomly pick where they're going to throw the decimal. They've decided that they don't understand the metric system, that it's too hard, that they can never figure out where the decimal goes. So you have to combat that, and you're going to teach them the order. And then the third thing you're going to do is teach them the idea of moving one place, one decimal to the right. I've seen this in Bob Jones, in Abeka. They have a little caricature of a southern boy with a piece of straw hanging out of his mouth and freckles and messy red hair and overalls on. And he says, metrics are downright easy. And I'm not going to attempt to say that in a southern accent, but you get the idea. So as I'm going down the metric system, I am going to use, I'm going to move the decimal to the right. All right, now 5th graders are new to the decimal system. They're new then also to the metric system. So what do I do in 5th grade? The 4th point is for 5th grade and even 6th grade is that you will have to drill and concentrate on procedure. 5th graders especially, they're going to be confused, so you're going to maybe bypass the idea of concept and really work on procedure. You're going to, in other words, allow them to use crutches. Okay, now this is kind of a crutch, and you can drill that down equals right. Metrics are downright easy. Okay, you can give them visual aids. As you're going up the metric chart, you're going to be going to the left and so forth. So, 5th and 6th grade, you will concentrate on procedure. All right, so let's go back to this. What's the first step of the teaching progression? What is it? Terminology. Followed by facts. We're not drilling the metric facts because there aren't any metric facts, are there? We're learning the terminology and we're learning the order. This would not be drilled with flashcards, it would be recited. So I'm not saying you don't drill it, but there are no metric facts per se. The measurement facts are all U.S. customary. 1 foot equals 12 inches. Those are measurement facts. Those do not exist in the metric system, do they? What's the next step? What's next? Concept. Procedure. Then what? Expansion. Then what? Problems. Problem areas, then application. All right, what I'm saying here with this last idea with 5th and 6th grade, sometimes you are going to give procedure prominence over concept when something's brand new. You're going to be drilling them on what to do. You're going to be drilling them on the order of the metric system. You are going to be giving them steps. You might actually tell them to write out the part of the chart that involves the conversion they're doing. Then you might tell them to move the decimal one place to the right, larger to smaller, multiply, so we're going to the right. They'll still know the fact from the U.S. customary system that when you go larger to smaller, you have to multiply. And what are we doing? When we move the decimal to the right, we are multiplying because we are getting bigger and bigger because we're multiplying by tens. So with 5th grade, you're going to have to kind of flip these around. Okay? right now, you're on the other side. You understand the concept, I hope. You understand the system. They will not. So when they have trouble understanding the system, you're going to center in on procedure. All right, so you're going to have them move the decimal one place each time, 5-1, and then we're going to move it one more place, so they end up with 345 and 1/10. Okay, so there is a progression in teaching from 5th grade to 8th grade. And many times the lower level and the newer material, we will do procedure first. This is the same thing happens with the percents. So the last thing with 5th grade would be lots and lots of practice. Okay? So we are going to put procedure ahead of concept with 5th grade and even 6th grade metrics. We're going to just be telling them what to do, what to do, what to do. And later on, hopefully we can catch up the concept. Okay? And that's the same thing is going to happen with percents I'm going to talk about in just a minute. What about 7th and 8th? First thing with 7th and 8th in teaching metrics is number 1, do not assume anything. We will need to address it from the beginning with 7th and 8th. All right, but then with 7th and 8th, we are going to begin here and we are going to go back. We're going to go back and pick up concept. So first of all, don't assume that they know the metric system. Reteach it. They're going to have problems with it in 7th grade. 8th grade, same thing, but to a lesser extent. So we will reteach it. Secondly, we will still keep it separate from the U.S. customary system at the beginning. Later, we will expand. We will address it and relate the two when we get to here. We're not going to mess with it right here. We're going to save it for the expansion step. So at the beginning, assume nothing, and then keep the two systems separate until we're ready to expand into the U.S. customary metric conversions back and forth. And we will address that, but not at first. All right. The second thing then is to keep the two systems separate until we're ready to expand. Third, we want to wean them off their crutches. In other words, wean them off procedure instead of do this, do this, do this. 3rd and 4th graders do a lot of this. They are taught to do this, do this, do this. Remember long division? Estimate, divide, multiply, subtract, compare, bring down. They're reciting steps. All right, we want to get away from reciting these in 7th grade. We're not going to be doing that anymore. But what we are going to do is we're going to start here and get down the idea of how the system works and how easy it becomes, and try to reach their understanding of why we are moving it to the right and not to the left. And they have to know the order, all right? Because then we are going to be having to deal with problem areas before we expand to the relationship between U.S. customary and the relationship between the metric system. So what we want to do, problem areas would be that they don't understand how many places and they don't understand which direction they go. Constantly, it's kind of like they get it or they don't get it. You'll have 7th graders that have no trouble moving the decimal point. They've figured it out. Okay, and then you'll have other 7th graders who it's so random, I can't even figure out what they're doing. They move it the wrong way, they move it the wrong number of places. That tells me they don't have the concept down. So in 7th and 8th, yes, we are going to assume they don't know the metric system, and then we are going to keep them separate, but then we need to wean them off the crutches by concentrating more and more on the concept, less and less of the procedure. So we've got to get the why down. We're switching this back. Why to back up the how. I guess I'll still have to do it at 2. But we want to start getting these switched back into their proper order. Then we'll be ready to expand them. So that's the last thing with 7th and 8th, expanding the metric system into junior high involves getting rid of the stair-step crutch, getting rid of the little sayings to memorize, and being able to intuitively know that if I'm doing kilo to meter, I know automatically that this is 3 places, okay? And I'm not going to go the decimal the wrong way because I know that kilometer is the largest unit, so the number that is represented in kilometer is going to be relatively small compared to meters. I know that if I have 450 meters, that's not even going to be a whole what? Is that even a whole kilometer? No, I already know the relationship between them, okay? So I'm already expecting this to be less than a meter. I understand the system. I can intuitively move the decimal point. That should be the goal by 8th grade. That's not going to happen if you don't work at it. Okay, so we want them to be able to intuitively move the decimal before we start hitting, we want to get rid of these before we start hitting the expansion. Because then when we get to the expansion, we are going to then relate kilometer to mile. We're going to relate meter to inch, not meter to inch, meter to yard and foot, and then centimeter to inch, and then realize that now we have a better tool. We have millimeter, and we even have micrometer, and we even have nanometer, and all kinds of things we can expand to because they will be using micrometers, all right? I don't think we'll be using anything bigger than kilo in high school, but do you see the point here? We want to expand our metric knowledge into junior high, into the intermediate, because we have got to be able to use it. We are prepping them for high school application. And we want them to be able to learn physical science concepts and physical science laws and be able to do the problems in science class. So to expand into junior high, we want them to be able to intuitively do this. All right? And we can less and less be dealing with hecto and deca. All right? So if you understand the concept here, you would never move the decimal the wrong way, ever. And sometimes students get lazy and they just put the decimal however, wherever they want. That happens with the percents as well. Right, so we need to be able to intuitively move the decimal doing basic metric to metric conversions. With liter, we know that milliliter is the smallest, and we know the relationship between the two, 3 places. Even centiliter, 2 places. So if I have 650 centiliters, I know the relationship between centa and base is 2, and I know that a liter is much bigger than a centiliter. I know that I'm going to be moving that decimal 2 places, right? I understand the system. That is the goal. All right, it's kind of a lofty goal for 7th grade, but it's a reachable goal for 8th grade, definitely for 9th grade. Otherwise, science teacher has to spend time on the mathematics. Okay, usually you do anyways. So we want to be able to intuitively do this. Also, don't forget the little quirk, because we are going to be applying this. What's the quirk about milliliter? Anybody remember? It's often interchanged for what?
Cubic centimeter.
Cubic centimeter. Remember, these are interchangeable. Whether they call them a cc or a cubic centimeter or a milliliter, those are the same size and they are interchanged. In fact, medical profession has completely gone to cubic centimeters. Physical science, not so much, but laboratories and that type of science, not so much. But your more applied sciences, your clinical applications use cubic centimeters. Okay, don't forget that. So we need to be able to understand the metric system. Here's our goal. We understand the metric system enough that I can just move the decimal point. I think most of you are at that point. It should have been very easy for you to do the metric sections, and everybody did very well. I don't know how much effort it cost you to do it, but the metric conversions at your stage are automatic. They are not for 7th graders, and you want to work towards it. So as we expand it, we're going to get rid of the crutches, and we want our students to be able to intuitively move the decimal point. They don't need a chart. They don't need the stairs. We're going to start with the stairs in 7th grade. We're going to try to wean them off the crutches, the stairs, the hand motions especially, okay? Then we will expand by relating it to the U.S. customary. We've talked at length of the U.S. customary versus the metric. They are distinct and different, but we do have to convert between miles and kilometers in everyday life. Okay, well, maybe not if you stay in your own little box, but we have to be able to convert, so we need to teach them that a mile is bigger than a kilometer. So we have to teach the relationship between the two size-wise and how to convert between them. And this is a fact that will be memorized. We want to limit it to those 4. But we do have to do a little bit of memory because remember, we're dealing with the U.S. customary system. We have to memorize numbers. So remember that, roughly speaking, 1 kilometer is approximately 5/8 of a mile. So you can approximate these, okay? If you, like I say, you cross into the border into Canada and you see that the speed limit is kilometers kph, just use your little handy dandy 8, right? 4 goes into 8 twice. 4 goes into 125. 5 times 25 is what? It's $1.25. Half of that is about what? Half of 75-ish, right? You see what I mean? So 5 times 25 is 125. We still have the 2 hanging out here. What are we going to get? We're going to get about 60, what? 65-ish. It's not going to be quite 70 miles per hour, right? So that'll give you a rough estimate of how fast you should be going. Don't be going past 70, you're going to get a speeding ticket. Or have a car that has a speedometer. I'm not thinking today. Odometer is miles. All right, so you know I better keep it below 70. Do most cars have a dual? I can't even think if mine does or not. I don't even pay attention to it. Does yours, Morgan?
My little Saturn?
Your little Saturn? If her little Saturn has it, then I'm sure all of them do. I don't know. I don't know either. Anyways, so the relationship between them. Okay, it's a good idea to have a rough idea. Because if we deal with anything internationally, we're going to be dealing with kilometers. So a kilometer is less than a mile. It's only 5/8 of a mile. Then we will have to deal with inch to centimeter using our ruler. Remember, it takes about 2.5 centimeters to make 1 inch. So inch is the larger measurement. So to convert in your head from centimeters to inches, you're going to divide by 2 and then think, I got to take even less off. So you want to have a good idea. So, or divide by 25 in your mind to help you with that. Then all we need for, whether it's gallon, quart, pint, we're going to go through the quart. Quart is pretty comparable to liter. Remember that, pretty close. A quart is 95 hundredths of a liter. That's pretty close. So when you are thinking in generalities, you can almost interchange the two. Almost interchange the two, and then just be aware of the fact that liter is slightly bigger than a quart. And you're going to teach this to your students. We've already reviewed this. All right? But there are a few things you're going to want them to memorize. This one, the 62 hundredths, and then also the 2.54 centimeters per inch. And then the only thing we really are going to work with is pound to kilogram. Keep in mind that they need to understand that a gram is pretty small. Gram to ounce does not work very well. What we would do is we would convert here, and then we would adjust down here and here. Of course, this is 3-place change. So this is really small. I got to put it down here because there's 3-place change between kilo and gram, isn't there? Okay. And then way down here is a milligram. Do we have anything here? No, that's why we can't use the U.S. customary system for science. We don't have small enough measurements. Okay. So we do need to know that a pound is smaller than a kilogram. It takes 2.2 pounds approximately to equal 1 kilogram. All right, so if you step on a scale and it's in kilograms, you're going to be about half of what you normally weigh. Okay, so we will at this point start doing the U.S. customary to metric measurement conversions, especially by 8th grade, and we need to have an idea of the relationship between the two. All right, so then we will eventually proceed to application and so forth, but we don't want to be dealing with this. Hopefully we've taken care of this at the beginning. Application will be done in high school, so we want to be able to do this on its own. We won't do so much application in junior high math with this. We'll do a little bit of conversions, certainly not much more than what I've had for you on your quizzes and your test. All right, so I think we're done with measurements. And so with measurements, your skills should be up to par, and you should have some ideas of what you're going to do when you teach it in 5th and 6th, and even 7th and 8th grade. All right, so I do want you to take your test by Friday. I am going to allow you to use a calculator because the test is not at junior high level, it is at college level. Okay, you'll have to do lots of conversions. You'll need to know those four. 1 kilometer is 62 hundredths of a mile. You'll need to know that 1 pound, or it takes 2.2 pounds to make 1 kilogram. And you'll need to know that a quart is only 95 hundredths of a liter, and then an inch is bigger than a centimeter, takes 2.54 centimeters to equal 1 inch. You need to know those. Like I said, we can do any practical U.S. customary to metric conversion using just those 4 facts. So we want to boil it down to 4 and not have them learn all these oddball things like meter to yard. We don't need meter to yard. Okay? We don't need feet to meter. So, all right. With the rest of this class period, I want to go back and deal with teaching percents. We spent all of our time on how to do percents and so forth, but as you think about the metric system, it is a new thing for 5th graders and 6th graders, and it's something that has to be mastered when you're done with junior high, or at least have a good handle on it. The same thing is true of percents. So these two ideas are very similar in teaching technique. Okay, they're very similar. And one of my biggest problems, worse than the problem with the metric system, I didn't have too big of a problem with the metric system. I'm still having a huge problem with percents in 7th grade math. We needed percents we're in statistics right now, and we need to be able to use percents for our statistics. And they're having a terrible time between when do I multiply and when do I divide. And they're totally focused on what do I do instead of what am I doing and why am I doing it and how does this work. They want me to tell them the steps. So it's very important in junior high that your students master percents. Okay, so if we look at the grand scheme of mathematics as they're coming up through grade school, junior high, and then high school. In high school, what do you think? What are we concentrating on in high school? Most high school curriculums, what are we concentrating on in high school math? What kind of math? What did you take in high school? Algebra and what? Geometry, a little bit of trigonometry, maybe a little bit of pre-calculus. What did you not do in high school? Very little arithmetic. Okay, and so then when we go to apply it or we get out in real life, what's one of the main things that you use in real life mathematics, real life arithmetic, let's say? Percents. Percents. We had a hard time with I am having to go back and I used my review days not to review how to do the statistics. I had to spend my review time reviewing how to find a percent. And even, here's what happened. We are doing circle graphs, okay? We're learning how to represent data graphically. And we couldn't do circle graphs. You know why? Half the class could not do this. This kind of illustrates what happens. I can't learn the statistics. I can't progress through to another branch of mathematics when my arithmetic skills are not intact. And my 7th graders do not have percent skills. So then we have to address this with our teaching. How do we teach percents? Why can't my 7th graders do simple percents? Here's the problem that we had. Of course, when you have a circle graph, or sometimes it's called a pie chart. How common is pie charts in statistics? Very common. It's used a lot to represent scientific data. It's used a lot to represent practical data. They couldn't make a pie chart, or as the book calls them, circle graphs, because each part of the circle, boy, I missed the center. Let me try to draw the center first. Each part of the circle is called a sector. Okay? And when you're drawing your circle, you have to know the measurement of the angles. So you do your, you have to find the percent, and then you have to find out what part of the circle. So they did okay finding the fact. We even did a simple problem with our candy. We have 4 kinds of candy. So I just made up this story problem about how many were mints versus turtles versus peanut butter versus the chocolate covered almonds. Okay, so I made up this is what we did. I thought, well, I'm not going to really worry about the percents. I want to concentrate on how we actually construct the pie chart. So here's what happened. I don't remember exact numbers, but I said out of 100 boxes, how much easier could I possibly have made this? What is percent? Part of 100. So I was trying to concentrate on how to construct, that looks awful, but oh well. I was trying to concentrate on how to construct a pie chart without tripping over the percents, and we tripped over them anyways. And I said, okay, out of 100 boxes, 34 of them were the pecan clusters that we all called turtles, just to be short. And then I said, out of that, I don't know, 20 were the peanut butters. Okay, so I'm at 54. So then let's say 16 of them were the mints. I don't know, the mints don't sell as well. Where am I now? I'm at 70, right? So then we'll say 30 of them were the chocolate covered almonds. All right, so I've got them to do this. 34 hundredths, right? We didn't even have to do any percent math. And that they had trouble with that. So I had to go back and review that percent is out of 100. So this is really easy. All right, then I didn't want to spend time on doing the percent math. I wanted to construct a pie chart. They didn't know how to find 34% of 360. I said, just find 34% of 360. And they were looking at me like, and several of them started dividing 360 by 0.34. 360 divided by 0.2. I said, no, don't divide, it's multiply, right? 34% of 360, you change the percent to a decimal and multiply by it. Or especially the peanut butters. 20% of 360 is simply 1/5 of means what? Times. And we were going around and around and around, and the class period ended before we actually got to draw our pie chart. Because we were tripping over the percents. So percents is a big part of intermediate math. So you need to know how to teach percents. All right? So let's start with 5th and 6th grade. And actually I kind of have to split 5th from 6th. So let's just start with 5th. And so what I want to do with teaching percents, I'm going to talk about when, why, and how. Get rid of the metric system. I am going to come back to this. Terminology, facts, concept, procedure, expansion, problem areas, and then application. This is especially for junior high. There's all kinds of percent application. Simple interest, I equals PRT, right? Discount, markup, commission. All right, so we've got a lot of percent application coming down the road, don't we? And we have to get our students prepared for it. Otherwise, I can't even get through the statistics chapter because I can't teach them how to do a pie chart without going back to the percents. Okay, so what I want to do then is when. First of all, 5th grade, percents are not even brought up until 5th grade, and they are introduced. Okay, they're introduced to the percent problems in 5th grade. So what do you want to do in 5th grade? You've got to do a good job of introducing the percents. Not going to do a lot with them. Certainly not going to apply them, or if we do, we're going to apply them very easily. So how are you going to introduce the percents? You are going to, this is a brand new concept. You're going to tether percents in 2 ways. The biggest way that you need to tether it is in the idea of fractions, even more than the decimal. You want to tether it to part of 100. Okay, remember my candy? 34 out of 100 is 34%. We've got to tie this, and we've got to make this connection. Part of 100. 100 in the denominator, relate it to fractions, and we still have to tether it to decimals. And we have to tether it to the 100th place. We don't want to just say, always move the decimal 2 places. That doesn't work. We want to tether, we're introducing it. We want to think of it as hundredths. So look, 34 hundredths, 34 hundredths, 34%. Percent means out of 100. Percent is hundredth out of 100. So we want to do a good job in 5th grade of introducing the percents by tethering them to both part of 100, which is fraction math, and then hundredths place, which is decimal math. And often we will do a little bit of application first. Okay? So we're going to introduce the percents by tethering and then by using them. I'm going to use this word here. Using very simple percents. So they're going to see kind of what they are and how we're going to use them. We're introducing. So when we introduce them, I am going to tether them to what they already know, and I am going to do a little bit of application so they can see what the value is of the percent. They can see where are we going with this. Okay? I'm not going to jump right into doing percent problems of their own. I will start doing procedure then. So I'm introducing the percents. I'm going to use them a little bit as my introduction. Then I'm going to proceed to simple percentage problems primarily, and then a few percent problems. By percentage, I mean by that is I'm going to have them do a little bit of procedure. Let me get this out of the way. So my procedure is going to be limited. I'm going to limit it first to very simple things like 25% of, 40. Pretty easy. I'm also going to do a little bit of 4 is what percent of 8? Very simple, basic percents that don't require a lot of decimal division. So I'm introducing percents in 5th grade, and I'm limiting my procedure in 5th grade. And then the other thing I'm going to do is I'm going to drill common percents. They're going to have a lot of you have a lot of decimal math with percent math, don't you? You have a lot of decimal multiplication, and worst of all, you have a lot of decimal long division. Students do not like doing decimal long division any more than you or I do, right? Do you want to do a decimal long division problem? No, and your mind says, that's what the calculator's for. And that's true, okay? So do you see what we're going to do in 5th grade? All right? So, 6th grade. We'll go back to this idea. My biggest problem teaching is I sometimes don't realize what people don't understand. So I have to force myself to start at the beginning. That's what I mean when I say assume nothing. Start at the beginning. This time you're going to probably do all 3 of these. You're going to go through them again, all 3 of them. You're going to introduce percent again. You're going to spend time with out of 100, part of 100. All right, but then your procedure will be expanded. And here's what you have to expand with your procedure. You have to start, you're going to start with these easier ones, but you have to be able to, you're going to spend a lot of time on converting percents back and forth between their decimal equivalent and their fraction equivalent, all the while you are drilling. You're going to start with 1/4. What is 1/4? It's 0.25 or 25 hundredths as a decimal, and then it's 25%. You're just adding a component to your drill, okay? so that when they see 1/4, they're going to automatically do 25. Then they can start concentrating on doing the harder percents. They can concentrate on applying the percents. They've already got their common decimal fraction percents. All right, I'm assuming that you know what those are. So let me give you a list. We have these guys are the money guys, right? We got a quarter, we got a $50, we have 75 cents. So all we're doing is we're expanding our drill to include these. And I'm going to drill this a lot in 5th grade, even though we're not going to be doing really that much with it. Then I'm going to go to the fifths next. These were easy, these fraction decimal equivalents were easy, so that means the fraction, that means the percent will also be easy. This is the same as 2/10 or 2/10. This is the same as 4/10 or 4/10. This is the same as 6/10 or 6/10. This is the same as 8/10 or 8/10. But it's also the same as 20 out of 100, isn't it? Now I'm going to add another 0. 20 hundredths, 40 hundredths, 60 hundredths, 80 hundredths. I'm constantly working in 6th grade with these equivalents. I'm teaching them how to go back and forth, and I'm drilling the easy ones. And I've already been drilling these. That's part of my problem with my 7th graders too. They don't know these. They act like they've never seen them. And I did say the word act, because sometimes some of that is all, we didn't have this before. Okay. And maybe if I stall the teacher enough, we won't have to do as much work. I think that's a student technique. A lack of, not a learning technique, but a try not to learn so much technique. Then we do have to deal with the repeaters. You remember these? We had to deal with them when we went through the percents for your review, didn't we? This is a repeating decimal. So what do I do with it? I will have to use its fraction equivalent, and this at the beginning in 6th grade is going to be memorization. They're going to have a hard time making this connection. It doesn't work as pretty as the fifths, does it? So I'm going to be working with these, and I'm going to show them why this decimal is a problem, because it repeats. And either I use the fraction or I have to round, which makes it an approximation, not the exact answer. This is also a commonly encountered repetition. It causes me problems. It's 16 and not 16 and a sixth. It's 16 and what? 2/3. So I'm going to be drilling these things. Okay, I'm in 6th grade. I am not drilling measurements. Are you? Well, the curriculum tells me to. I wouldn't. If I do, I might pull them out once in a while, but I'm drilling stuff that they need. This also is a repeat, but notice we're back to a repeating 6 and a repeating 3. So this is not 83 and 5/6, it's 83 and a third percent. So in 6th grade, I am working with the drill that I started in 5th grade. All right, so when I have my drill time, I'm not wasting it with 5 times tables and 6 times tables and 12 times tables, and certainly not the 10 times tables or the 11s for that matter, right? What am I doing? I'm drilling what I need to drill. Okay, we get a lot of criticism because we drill and we make them stand up and recite and memorize. Well, this is going to help them. So yes, let's memorize stuff that they need, and this will help them in their percent math. It is kind of a crutch, but then eventually we're going to work in junior high to reach more and more of their understanding. All right, so then in 6th grade, we are going to start over. We're going to do these 3 things. We are going to drill our common percents, but then we've got to work on this, and we have to then expand it from just doing easy ones to doing harder ones. 36% is 0.36, or 36, which is 36 hundredths place, or 36 out of 100, and then we have to reduce this to 9/25. So now we're going to have to start going back and forth between ones that are not common, ones that are not memorized. So in 6th grade, we've got to work on this. We are going to expand our procedure. We're not going to limit it to the easy things, and we are going to expand our procedure. We've got to be able to do this. And then we have to do all 3 types of percent problems. Remember when we reviewed this, we have percentage problems. What number is 36% of, I'm kind of stuck on 36, but we'll say 50. Or, so what number is 36% of 50? Look at the fraction. 36% is 9/25. I picked the easy one, so what is it? It's 18. Then we have to do 18 is what percent of 50? All 3 types of percent problems. And then we're going to say 18 is 36% of what number? So the percentage, or the part, the percent, and then the base, or the total, or the whole. 3 types. And the different textbooks call them different things. Here we're missing the part, or the percentage. Here we're missing the percent. That one's easy. Here we're missing the base number, or the total number, or the whole number, depending on what. So we have to start working these. And how are we going to do them? We're going to concentrate on procedure, and then we're going to begin application. Kind of doing how at the same time. All right, so when I'm doing 5th and 6th grade, I'm going to be doing a lot of drill. I'm going to be doing a lot of procedure. I'm going to try to get my concept in as much as I can. But this is going to be very procedural driven. How do I do percent problems? That's what 5th and 6th grade is all about. How do I do them? Then when I get to junior high, I am going to seventh grade and 8th grade, I've got to transition away from procedure. So I'm going to review and solidify the 2 things. The common decimal fraction equivalence, the common decimal fraction percent equivalence, and the 3 basic types of problems. So basically what I'm doing is I'm reviewing and solidifying procedure. Then I have to get to concept. I have to really stress the idea that percent is part of 100. That percent is the hundredths place, and any computation that I have to do, in percent math, I have to do it as a fraction or as a hundredth, as a decimal. Okay, I can't do any of these, so I have to start concentrating on concept. What does percent mean? Why is it called percent? How do I work with it? What am I doing? I'm actually not doing a whole lot more than I did with fraction math. I'm dealing with part of 50. What part of 50? And then I'm just changing the form that I'm expressing my answer in. Okay? And this is the whole number. So this is the denominator, in a sense. This is the numerator. And then this is just another way to express the value. So I'm working on concept. I'm solidifying and reviewing procedure, and then I've got to get the concept down, and then I'm doing more application. Eighth grade, I have got to go back and get the concept and the procedure. Hopefully it is a review. It may not be. So I am going to review and solidify concept and procedure. Then I'm going to expand my application even more. A lot of application, and there's all kinds of percent application. There's percent of increase and decrease. There's markup. There's profit. What is profit? How much is marked up? Cost versus selling price. Discount. Then there's commission, rate of commission, and all kinds of things. There's all kinds of expansion. So percent math is one of the top goals. So in the Y, percent math is an essential arithmetic concept that may not be repeated much in high school. It's an important concept of arithmetic that may not be repeated as far as teaching goes in high school. It will be used in high school. The next thing. It's not going to be retaught in high school. It's going to be used in high school. So first of all, it's an important concept of arithmetic that may not be retaught in high school. It's going to be used in high school. Okay? And then the last thing is, not only is it going to be used in high school, it has numerous real application. This has got to be one of your goals of intermediate math, is that your students are where they need to be with their percent skills. All right, I think with 4th grade and 5th grade, you're working a lot with fractions and decimals. So this is not really a goal of 5th grade, but it's got to be a goal in 6th, 7th, and 8th, especially 7th. All right, so what I had to do with my 7th grade this year is I scaled back the geometry a little bit, and I had to spend time on percents. So we're a little taken for a loop when they couldn't do the simple percents on the stats section. I think they had it in their mind they were doing statistics, and they could forget percents. I had to keep telling them this isn't history class, so that when we're done with the Civil War, we're done with the Civil War. Are we ever done with percents? No. Are we ever done with fractions? No. Are we ever done with decimals? Are we ever done with division? No. So we have to make sure that percents is an important part of intermediate math. Okay, so don't skip it, don't downplay it, make sure you teach it.